Good morning everyone. Today we will discuss few numericals and few important questions related to the chapter 1 solution. Okay. So our first question it is, which of the following aqueous solution has highest vapor pressure at 300 Kelvin? First you should look here the compound that is given to you. It is 1 molar sodium phosphate, 1 molar calcium chloride, 1 molar potassium nitrate and 1 molar glucose. Okay. You can see here all the compounds leaving the D option are ionic compound. They all are electrolytes. Okay. So for that we have to use the value of I. Okay. I is equal to 1 we are using for non-electrolyte. Okay. But here glucose only the compound that is non-electrolyte. Okay. So I it's become equal to 1 only for non-electrolyte. And it is not equal to 1 if you are taking the electrolyte. Okay. So you can see here electrolytes sodium phosphate, calcium chloride, potassium nitrate all are having some values of Van Hoff factor, that is 4 for sodium phosphate. Why it is 4? If you will dissociate sodium phosphate Na3PO4 into ions, how many sodium ions will be formed here? It is 3 sodium ion. Okay, and how much phosphate ion? Only 1. So total number of ions it is 4. So I value will becomes equal to 4. So in the same way you have to calculate for calcium chloride. Calcium chloride will give how much ions? 1 ions of calcium and 2 ions of chloride negative. Okay. In the same way for potassium nitrate. So here for calcium chloride the value it will be 3 and for potassium nitrate the value will be 2. Okay. So you can see here if glucose you will take, then I value is equal to 1. So what is the relation between the vapor pressure and I? You can see here greater the value of Van Hoff factor, lower the vapor pressure. Okay. If value will be more for I, then vapor pressure will be low because it is inversely related to with each other. Okay. So you can see here in glucose only the I value is equal to 1. In other cases the value of I it is more than 1. That's why in this question it is asked which is having a high vapor pressure. So which is having the less value of I, that will have the more value of vapor pressure. Okay. So that's why the answer will be D option. Now our next question it is, 1 molar aqueous solution of electrolyte A2B3 is ionized 60%. The boiling point of the solution at 1 atmosphere for this compound is 0.52 Kelvin kilogram per mole. Okay. KBH2 for water is 0.52 Kelvin kilogram per mole. Okay. So this constant value it is given to you. The compound is A2B3. Okay. So options these are given here. How you have to solve here? First you should know this compound will dissociate. Okay, because here word written ionized. If you will break the compound A2B3, then how many ions will be formed? Total 5 ions. Okay, how many ions will be formed here? 5 ions. Then value of N is equal to 5. Why we have not taken here I is equal to 5? Because it is only 60% dissociation. If it will completely ionize, then N will becomes equal to I. Okay. So otherwise you have to take the number of ions that is equal to N. Okay, N. So for dissociation which formula you are using? I is equal to 1 minus alpha plus alpha N. Okay. So value of alpha, the degree of dissociation, it is given to you 60%. So now it is equal to 60 by 100. Okay. Now it is equal to 0.6. So alpha value you can put here. N value it is given to you, that is 5. Number of ions formed it is 5. You can solve the value of 5. Okay. So after calculation you can see here it is solved. So after calculation I value we will get 3.4. Okay. So now what they have asked, boiling point of the solution. Okay. So how you can solve? You know very well delta TB is equal to I KBM. Molality it is given to you, that is 1 molal. You can see here in question also. KB value also given to you. I we have solved. Then you can solve the delta TB. Okay. Okay, so it is given to you, that is I is equal to 3.4 that we have solved. Kb it is given to you, and molality it is 1 molar. So after calculation you will get delta Tb. That delta Tb we have got 1.768 Kelvin. So as we know very well, delta Tb is equal to T solution minus T naught. Okay, T naught it is the boiling point of water. Okay, as boiling point of water it is in Kelvin, it is 373 Kelvin. Okay, delta Tb we have solved from there, so you can put this value here, you can solve the value of Ts. So after calculation you will get the value of boiling point of solution 374.76 Kelvin. Okay. Now our next question it is, which of the following has equal boiling point? 0.1 molar Na2SO4, 0.1 molar sucrose, this is the chemical formula of sucrose, MgCl2, and 0.1 molar aluminum nitrate. Okay, it is not a molar, it is a molarity. Okay, so you should know which one is having equal boiling point, which will have the same value of Van Hoff factor. It means those compounds which are having the same value of I, they will have the same boiling point. Okay, nearly equal to the boiling point, equal to each other. Okay, so now you can see I value for sodium sulfate. How many ions will be formed? Na2SO3. How many sodium ion? 2. 1 ions of SO3. So total it will be 3. Okay. In case of glucose, I value is equal to 1. In case of magnesium chloride, I value is equal to 3. In case of aluminum nitrate, I value will be 4. Why it is 4? How many ions will be formed? Aluminum 1 and nitrate 3. Total will be 4. So you can see here the same value of I, it is given for sodium sulfate and magnesium chloride. Both are having I is equal to 3. Okay. So the answer will be A and C option. So you can see here value of Van Hoff factor it is given. Okay. In case of sucrose, I value it is equal to 1. Why we have taken is equal to 1? Because it is non-electrolyte, it will not dissociate into the ions. So now you can see here, next question, in a closed container, vapor pressure of liquid depends upon volume of the container, temperature, volume of the liquid, and all of the above. Okay, vapor pressure definitely depends upon the surface area as well as on the temperature, but according to option we have to go here, it's the volume of the container. So it does not depends upon the volume of the container. Okay, it depends upon temperature. Why? If you will increase the temperature, definitely the vapor pressure will increase. Okay, so volume of the liquid it will not matter because it is closed container, and definitely the volume will remain same in that only. Okay, so explanation you can see here, tendency of material to change into gaseous state, it is called vapor pressure. Okay, so it depends upon temperature. If you will increase the temperature, definitely the kinetic energy will increase. Okay, if kinetic energy will increase, then vapor pressure will increase. So now you can see here next question. Which of the following observation demonstrate colligative property? Definitely that will have the value of I. That will shows the colligative property. You can see here in option A, 0.1 molar NaCl solution has high vapor pressure than 0.1 calcium chloride solution. Okay. B option, 0.1 molar QS solution freeze at lower temperature than pure water. Pure water freeze at higher temperature than pure methanol. So which option will be the correct one? You can see here 0.1 molarity, 0.1 molarity, both are same in both the case of compound. Okay, so it depends upon the number of ions. Okay, so in sodium chloride solution it has high vapor pressure. As we know, I value is inversely proportional to vapor pressure. Okay, if I value will be more, then vapor pressure will be less. If I will be less, then vapor pressure will be more. So in case of NaCl, I value it is equal to 2. And in case of calcium chloride, I value is equal to 3. How many ions will be formed? Total 3. Okay, so less value of I will shows high vapor pressure. So that only written here, it means it is correct. In case of B, 0.1 molar KOH solution freezes at lower temperature than a pure water. So inverse relation it is given here. Okay, so option B also it is correct. So explanation you can see. So now our next question it is explain the diagram below and select the appropriate option. Okay, this is given to you 0.1 molar KCl solution and 0.05 molar calcium chloride solution. Here in between the semi-permeable membrane it is used here. Okay. So whenever we are using the semi-permeable membrane, it means we are looking here the flow of solvent molecules. Only the solvent molecules can pass through the semi-permeable membrane. It will not allow the solute particles to move through it. Okay. So you can see first option it is given here. There will be no substance movement across the membrane. Definitely something will move. Water movements will take place. Okay. Because it is osmosis. Calcium chloride will flow towards the KCl solution. No. Calcium chloride solution will be approached by KCl. No. Why? Because these two are solute and it will not allow the movement of the solute. Okay. We have made a solution. It will allow only the movement of water molecule. Now D option. The osmotic pressure of 0.1 KCl solution is greater than that of 0.05 molar CaCl2. Assume it complete dissociated. Okay. So you can see here osmotic pressure. You have to solve for that. Pi is equal to ICRT. Here R and T it is taken as constant because R it is already a constant and temperature also constant kept here. Okay. So definitely it depends upon the I and C only. I is Van Hoff factor and C is the molarity. Okay. So you can solve by this I value. It is 2 for KCl. How many ions will be formed? 2. It is completely dissociated. That's why I will becomes equal to N only. N number of ions formed. I for calcium chloride it is 3. Okay. So now you can see here molarity it is given to you 0.1 for KCl and 0.05 for calcium chloride. So osmotic pressure it depends only upon I and C. Okay, RT it is kept constant. So I and C you can use for both the compound. Okay, so now you can see here the calculation. For KCl, pi is equal to ICRT. It is kept constant. I for KCl it is 2. Okay, how many ions formed? 2. 0.1 molarity it is given to you, concentration. After calculation you will get the 0.2. For calcium chloride, pi is equal to 3 into 0.05. 3. What is 3 here? It is the value of 5. We have solved calcium chloride. How many ions formed? 3. After multiplication you will get 0.15. So D option it is correct. Osmotic pressure of KCl it is more as compared to calcium chloride. So now next question it is given to you. When 0.643 gram of compound is added to 50 ml of benzene, density it is given. The freezing point of is reduced from 5.51 to 5.03 degrees Celsius. What is the compound's molecular mass? Kf for benzene it is 5.12. Okay. What is asked here? Molecular mass. Okay. So first you should know the chemical formula of depression in freezing point. Okay. It is related to freezing point. So it is delta Tf is equal to Kf into M. What is M here? It is molality. Okay. Kf value it is given to you. That is 5.12. Okay. And molality it is equal to moles by mass of solvent. Okay. It is equal to moles by mass of solvent. Okay. Into में Kf is equal to delta Tf. Okay. So what you have to solve here, first you can solve the moles. After calculation of moles, you can solve the molar mass. Okay, so everything it is given to you. I will write here again, delta TF is equal to KF into molality is equal to moles by mass of solvent, and moles again we will open, it is equal to given mass by molar mass into mass of solvent, that I have written here with the help of W1 into 1000 if it is given in gram, but here it is given in kilograms, then no need of this. Okay, so delta TF it is given, that is 5.51 to 5.03. so delta TF is equal to T naught minus TS. Okay, so T naught value it is given to you 5.12 minus 5.03. Okay, so this value it is given to you. After calculation you will get the delta TF. Okay, then you can solve the molar mass. Okay, every value it is given. So delta TF after calculation, this value it is given, delta TF, KF it is given to you, this molality it is equal to given mass by molar mass. Molar mass I have written with the help of Y. Okay, into mass of solvent. So after calculation Y value it is 156 gram per mole. Okay, so our next question it is, the unit of cryoscopic constant is option A kilogram per mole per Kelvin, C Kelvin kilogram per mole, D mole kilogram Kelvin. Okay, so answer C it is given to you. Okay, so what is cryoscopic constant? Actually it is the other name of KF. Okay, so we know delta TF is equal to KF into molality. So you know the unit of molality and delta TF, you can solve KF. After getting the answer, okay, you will get Kelvin kilogram per mole. Okay, so this is your the answer. So explanation you can see here, it is given to you. Okay, delta TF it is Kelvin, molarity it is moles per kilogram, unit of KF it will be Kelvin kilogram per mole. So in next video we will discuss the numerical question number 9. So you have to do up to this only. Thank you and have a nice day.